Hello everyone. This is Nakano from Japan Unix. Today, I would like to share 3 tips for avoiding failures when introducing soldering robots and automation. Actually, we've sold thousands of robots to our customers in the world over the last 30 years. We have had customers who have succeeded through the entire processes from installation to startup, and some who have had several problems and issues along the way. So, what makes differences one from the other? Thus, I would like to share 3 key points for how to start successful robotic soldering automation. Okay, the first tip is pre-testing. If you're buying a soldering robot without running pre-test, it will increase the risk of failure. So, what kind of tests are we talking about? The key is the process. You have to explore the theoretical question of what leads to successful soldering, and the practical concern of what causes mistakes. People say about soldering as a craftsmanship skill. But when we hear craftsmanship, that can make it seem harder to grasp. Thus, what we do is to break it down in details, and to express it in logical, numerical form, then visualize it. When you understand the process, you will be able to determine what kinds of problems can occur during mass production, and create strategies for dealing with them. The second key is positional accuracy. There is a tendency to think that because these are robots, any issues will always happen in the same position. But, there are actually 3 positioning-related factors that need special attention in soldering, and I'd like to speak about them. Let's start with number 1. The tip of the soldering iron is the part that comes in direct contact with the product. It also transfers heat, and the surface it touches can expand, altering the size of the product. Of course, there will also be some wear on the tip due to the repeated contact. Will the quantitative properties remain the same in an area where heat is being applied? You are likely to see some variation. Next, there's the solder feeder. You may know that wire solder is made of metal, but does that mean it's solid? In fact, solder is a liquid. On the tip of the iron at upwards of 220 degrees Celsius, the solder is in liquid form. Let's think about how liquids work. In the shower, for instance, there's the way the water flows over your left shoulder, over the right shoulder, and the way it trickles downward. Solder is the same in that regard. Are the ways a liquid goes to the right and left, and the ways it flows and trickles downward all going to be the same? There are probably going to be some slight differences. So, the behavior of the liquid from a solder feeder will also have an influence on positioning. Number 3 is the product being worked on. For this example, let's assume that I'm like a component lead. This is an through-hole lead pin. Let's say we're inserting it in a mounting hole. However, we know it's not going to fit perfectly. There is a bit of space left. Thus, the pin will shift to the right and left. Let's say the tip of the soldering iron makes contact here. The heat could be applied with the pin toward the right, or with the pin toward the left. Do you think the outcome will be the same either way? No, there will probably be a slight difference. There will be some parts of the finished product where this can't be prevented completely. In positioning, there will be ranges of variation. What will those ranges be? How do variations in positioning happen? And how can they be reproduced? Carefully considering and accurately ascertaining that, and maintaining repeatability and measurability will help you to achieve consistent quality in mass production. The third key point is maintenance. Of course, having no need for maintenance at all would be perfect. That is something we are working toward, but for now, there are still some parts that do require maintenance. In soldering, thinking about what maintenance is necessary and creating a plan are important steps to take. The first maintenance issue is a periodical replacement. I spoke earlier about soldering iron tip. So, the tip is one thing that will need to be replaced periodically. Sometimes that might mean changing it once every 2 days, sometimes once every 5 days. Changing them whenever you feel like it can create issues in terms of repeatability and production quantities. It's something that needs to be done on a consistent, regular basis. Next, there's regular cleaning. On that subject, solder contains something called flux. When the flux in the solder evaporates due to the temperature when soldering, it will get stuck to the arm of the robot. If this builds up, it can form an icicle-like protrusion. As you would expect, that can affect the way the robot moves. This is why regular cleaning is necessary. Number 3, regular inspections. Robots, of course, will reliably give you the right temperature. At the same time, it is important to make certain of this aspect of their performance. That is the most important thing when it comes to soldering. It may seem like a hardship to have to do so many things on a regular basis. In the automotive industry, there's a saying, no downtime allowed. It means that keeping production going and avoiding stoppages as much as possible is paramount. In other words, it's about avoiding expending time and effort on the unplanned, and avoiding working off schedule as much as possible. That means thinking carefully about the maintenance part of the process. Doing these things regularly, and simplifying and consolidating them as much as possible, will help you raise your quality rate. Let's review, starting with point number 1. Properly testing in advance will help you get the best results. Understanding the process is critical. Key number 2, positional accuracy. We went over 3 positioning issues. You need to be sure you know where repeatability and measurability are coming from. Key number 3, maintenance. Unfortunately, maintenance is something that will be necessary. Thinking carefully about where maintenance is needed and making a plan. That is an extremely important thing to do. For details on any of these points, please contact us at Japan Unix. We would be delighted to work together with you on your soldering automation project. Thank you for watching.